Okay. First of all, tonight's meeting is being recorded, and I'll send out the link to everybody that registered after we clean it up and everything, and get it posted online. Tonight's meeting is Kill It with Fire, Managing Aging Computer Systems and Future-Proof Modern Ones. It's a book by Marianne Bellotti, and she's going to be talking. Yep, there she is, showing the book. And Johnny's got his copy. I can show you my iPad that's got the same book on it, but it's not quite the same as a physical book. Let's see. It's being co-hosted. This meeting's being co-hosted by quite a few groups, as you can see. I won't go through and list them all. Just in case you're wondering who's signed up to attend, we've got people from 5 different countries, and within the U.S., you can see all the states and territories. So a wide audience there. And I'm going to go ahead and stop here and let Johnny take over. So let me stop sharing my screen. Johnny, do you want to go ahead and share yours?
Yeah, I guess I can. Let me pull up the slides.
Well, while you're doing that, I'll mention to everybody that the attendees are muted. If you want to put a question or something in the chat window, go ahead. I'll be keeping an eye on that. And if you want to actually say something, just raise your hand or put a note in the chat and I can unmute you.
Okay, first caveat is I can't see anything while I'm presenting these slides, so you'll have to give me like a verbal cue when you want to go to the next one. But I had the great privilege of working with Marianne and her talented team on a modernization project in one of my previous jobs, and it was such a great experience working with them, and the energy that they brought into the organization was just awesome. And when I saw that she'd written this book, I went out and bought the book, and I can honestly see areas in the book that kind of were very familiar to me when it comes to some of the stuff we worked on. With that, I would like to introduce Marianne Bellotti. If you would like to go ahead and say a few words about yourself and your book, that would be. And if you want me to update the slide deck, just say next slide or something.
Well, I can't actually see the slide deck, so I think
we're not seeing your slides yet, Johnny.
Okay.
But I can share it from, or I can try to share it from my side if that's easier.
Oh, you have to hit the share. Okay, there we go. Now I'm going to go to the full screen again. There you go.
I know. I love Google Drive, but Google presentations screen sharing is very, very complex. So we can go through. I came with a little bit of a deck because I like having a visual reference for when I'm talking. I think the plan for tonight was to do just kind of a basic introduction into who I am, then to some of the themes of the book, and then kind of opening it up to more fireside chat, Q&A, discussion type area. So for those of you who are like, to PowerPoint slides, bear with me. It's just a couple as like a visual aid. So hit it, Johnny. Let's advance the slides and get the show on the road. All right, cool. So a little bit about me. First of all, I'm the author. I'm the proud author of this book right here, Kill It with Fire. My name is Marianne Bellotti. I've been a software engineer for over 20 years, How far over 20 years really depends on whether you count the script kiddie stuff I did when I was 13 years old or not. I tend not to count that as part of my professional experience for obvious reasons. But I grew up in a family that programmed computers, in a household that was full of computers, and just kind of like inevitably transitioned into this role in technology. But before I transitioned into this role of technology, a lot of what I was interested in was actually more social science related, in particular anthropology. And when you read the work that I do, both as a writer and also as a manager and a person who builds and runs engineering teams, you can sort of feel the influence of the social science discipline in my approach to working on projects. So right now, what I consider my specialties as an engineer to be is really kind of system dynamics approach to looking at computer systems, especially dealing with formal methods and architecture and system rescue. I joke that I like great trash fire, which is a large reason why there is a dumpster fire on the cover of the book. Like, I am drawn to technology that is failing and organizations that seem to be struggling to manage their technology. I find that I learn a lot and get a lot of value out of those kind of environments. And also that the impact that I can make when we're able to make improvements to those kind of environments is way more significant than the organizations where things feel like calmer and more predictable. So right now, on that note, right now I am an engineering leader at Rebellion Defense, which is a small, relatively young defense startup focusing on software as a service at the DoD and the very scary notion of AI, which I particularly enjoy because I get to be very tactical around safety issues, which I think is like the forefront of technology and the conversation around technology moving forward. So next slide, Johnny. So one of the biggest things that people, after they read the book, kind of ask me about is that the book has a very aggressive title, right? It's called Kill It With Fire. And again, there's the aforementioned dumpster fire on the cover. And so the appearance, the impression you get from looking at the cover of the book is very aggressive and cynical. And yet my feelings about modernization and legacy systems is this is wonderful. And that's the tone of the book, is that legacy systems are great. I love working on them. Here's why you should also love working on them. And here are all the things that I've learned working on them. And the contrast between those two things. Legacy systems are, and modernization is really difficult, right? And so I don't think anybody needs to read these stats, but I have them. So I like putting them up on slides so that people have like an actual reference. But like, it's hard. A lot of them fail. And some of them fail in spectacular fashion, overrunning their budgets by many, many orders of magnitude, and their schedules by many orders of magnitude. But I always tell people that a legacy system at its heart is a successful system. Because if it wasn't a successful system, people weren't using this system, that we would have the easiest modernization path in the world. We just turn the damn thing off and forget about it, right? It's only because these systems provide utility and value and that people are using them often to do extremely important things, that the challenge of modernizing these systems without disrupting that becomes really like in the forefront. But I think the biggest challenge in legacy modernization is that people gravitate towards this sort of silver bullet type thinking. They want to know, what's the one thing that I can do that works all the time with every single project? And there is no such thing. So a lot of what I was trying to do in the book is dispel that notion that the whole thing is hopeless, because it's not, or that everybody should do this one thing. Like everybody should move to the cloud, or everybody should like get off their mainframes, or everybody should rewrite everything in like, I don't know, Haskell, right? I wanted to dispel this notion that there was any one approach that was going to work for everybody, and get people to really appreciate the contextual side of software. So next slide. This is a picture of a sticker that I bring with me to conferences, and that occasionally I send people if they ask really nicely. And it reads, all software is garbage. And it just perfectly, I made it because it perfectly sums up my feeling about the biggest challenge we have in technology. You can kind of move the slide forward, Johnny. Which is that people have this perspective about technology that the decisions that you make as a person in software or as a person in technology, they're either right decisions that are always correct and work forever, or they're wrong decisions that you should be ashamed of. And everybody is very afraid of making a wrong decision that they should be, that they will be, that will mark their career for life. And so they get very, very obsessive about making sure that all their decisions are technically correct. And again, this idea that technology is contextual and that context changes. So a thing that I would do quite frequently with my teams at the time that Johnny knew me, and still to this day, is I would have them do an architecture of the system we were trying to rescue in the time that the system was developed. Meaning that if the system was developed in, say, 2007, you could only use the technology and approaches that existed in 2007. And it's amazing to me. Well, it's not really amazing, but it's amazing to them how often they start off going, yeah, I'm going to do it this way. And then we can kind of pick apart that wasn't invented until like 2014. That wasn't popular until like this happened. That didn't exist. You know, sort of pick apart and pick it apart and pick it apart. And we end up with an architecture that looks exactly like the system that we have in front of them. And so I think when we learn to appreciate the contextual nature of technology, we learn to humanize it, but also develop great empathy for the software engineers that often we are taking over for. And once we have that empathy, we can sort of figure out how to thread the needle around like what are the current needs and the current scenarios, and what are those technical decisions that we need to make right now. So, Johnny, one more slide. Actually, there might not be one more slide. So again, this is kind of the slide that summarizes what I've just talked about. Like the technology is about solving problems, and we don't build technology for the sake of building technology. We have something we want to do with it. And often the context around those problems is unique to a particular people at a particular time, and it's all changing all the time. So similar organizations may feel like they had the same problem, but because of their particular place in the market or their particular collection of people or other factors, they may actually have different problems that they need solved. And so a lot of what I deal with people when we're talking about like how do we plan this out is less about like the technology side of things and more about like what does the organization actually value? What are the incentives that are in play? Where do we want to invest in this organization? Because where the organization actually wants to invest is a huge determining factor in like what modernization plans are going to work and what modernization plans aren't. The big example of this for me is that age-old question of we have a mainframe and a bunch of COBOL applications. Do we rewrite it all in something else? Or do we hire a bunch of people fresh out of college and train them in COBOL? That is really a question of where you want to spend your training budget, right? Because if you rewrite it, you have to make sure that everybody who is working on the new application knows the language it's written in. So you have this choice of taking the people who've been maintaining the old application and retraining them to run the new application, or moving them on. But if you choose to move them on, they will know that. And then like you are putting them in a situation of essentially working themselves into the unemployment line, which is not a great motivating factor for anyone, right? So when you look at these projects, you see like all of these little like questions where you could successfully modernize it with this approach, or you could successfully do it with this approach. And the difference maker is where we actually want to spend our resources as an organization. So I think of it mainly about a set of trade-offs, and that as an organization grows and matures, those trade-offs tend to shift. And so keeping the technology both in line with modern best practices, but also with the trade-offs the organization has agreed to accept. So next slide. Yeah. And so if you're thinking to yourself, a lot of this sounds very much like Conway's Law, and I'm a huge fan of Conway's Law. And I reference and do deep dives on Conway's Law and the appropriate way to leverage Conway's Law quite a lot. Conway's Law is primarily about this idea that technology looks like communication pathways and incentives. And that's true. And I also think, as I mentioned before, that the available solutions and popular approaches at the time have a huge influence. The scale that an organization is operating has a huge influence. And then in the context of that moment, engineers see threats and risks very differently. I think we're seeing that play out right now with the question of encryption and the advent of quantum computing. 5 or 6 years ago, there were a lot of engineers that were very blasé about data leaks when the data was encrypted. The attitude was like, yes, it's unfortunate we had a security incident, but all they got was encrypted data, and we used the best class algorithms, so it's fine, right? And now the lifespan of those best and first class algorithms is shortening pretty dramatically. And so people's attitudes about exactly what that threat is and exactly what that risk is have shifted with that advancement. And so a modern solution, and in fact, I don't particularly care for the phrase modernization at all. I tend to prefer to think about it in terms of like operational excellence. And so what I tell people is that if you can run it, maintain it, and respond to incidents on it, you can onboard new engineers on it. I don't care what it's written in. Like, you could literally have put 3 monkeys in a box with some gears, and that's what the technology is. And like, if it meets your SLOs and you can maintain it over time, that sounds great to me. Like, I do not care what the technology is. And I find these debates about whether technology is too old to be somewhat absurd. It's really about your ability to operate it and maintain it. But when we do talk about modern solutions, it's not just about rewriting it in a different, flashier language or putting everything in the cloud. It is about aligning the organization's values and incentives and its context with what the technology is and what it's doing. So next slide. I think this is where we're going to open it up for questions. I know Johnny has some questions that we sort of pre-prepared, but also please feel free to put your questions in the chat. I'm very interested in like what people.
Yeah, so when we're defining a legacy system, what do you think is the difference between code that is merely old and something that is truly legacy?
So I've always really liked Michael Feather's definition of legacy systems. For those of you not familiar, he wrote the book Working with Legacy Code, which is very in the weeds around the structure of legacy software applications, slanted very heavily towards Java, but that's fine because there a lot of software engineers know Java. And his definition of legacy systems is kind of, when you first hear it, it sounds like very like unintuitive, right? He says that legacy systems are systems without tests. And my first reaction to that is like, well, that's oversimplifying. And then I thought about it, because like when your system doesn't have tests, there's no way for you to really reliably make changes to it under knowing that those changes are not going to have negative impacts. And I've always said like tests are the first form of documentation I look at. I don't really care what your README says. I care what your unit tests say, because your unit tests tell me how you think the system is going to behave, or your integrations tests tell me what you think the system should be doing, right? And so there's an incredible amount of data that I learn from looking at your tests before I look at anything else. And so when I thought about that statement, I was like, oh, that's actually quite clever. So that's sort of the way I think about it as well. When you don't have the ability to maintain that system anymore, then you have a legacy system, and that's what we need to resolve.
And I know one of your legacy modernization projects you worked on in the past, but what are some of your other legacy projects that you worked on in the past?
Well, I'm not going to name names. I'm going to try very hard not to name names, because nobody is proud that they get stuck in that situation. But my favorites are always the ones that I did when I was in the federal government. Not just the one that you and I worked on together, but there were always like this never-ending supply of really interesting legacy modernization projects. And it was not like, I think people got very cynical about it, and they were like, well, the government just, is terrible technology. For me, what was really interesting was the whole system that was that created these circumstances, because often what would happen is that all of the technical work was outsourced to contractors, right? And there's a very compelling argument for why that's the right thing to do. But then government being government, they would inevitably go, oh, well, it's only fair if we compete this contract after, let's say, 10 years, right? Because we want to make sure that the American people and their tax dollars are getting the best deal. And all of that is very, very sensible, right? But it results in a lot of the institutional memory of that system and that engineering team being completely lost, right? And then I would watch contractors do things that were like incredibly destructive based on like the rivalry and the competition that they were set up between each other. They were incentivized to do things that were not good for the overall system health. And I always found myself in these situations where every single person involved or party involved was behaving completely rationally. And in a lot of ways, there weren't any bad guys. There weren't many people that I could point to and say, like, you were not thinking about the health and welfare of the American people or the mission, right? A lot of times people were thinking about those things, but they were set up against one another in ways that were like completely counterintuitive, or where they were not going to be able to collaborate effectively. And that was what created a lot of these failure heavy, like essentially decades of failure history scenarios. And I found that fascinating and learned so much from being in the middle of those kind of circumstances and trying to figure out, like, how do we align all of these groups of stakeholders correctly so that the decisions that we all know are the right decisions for the technology are getting made and then like finalized and cross the finish line on them.
Yeah, I think we had a question in chat.
I'm not seeing any questions in the chat.
Okay. I could have sworn I saw something come through.
Oh, I see it. One cannot
It could have been.
continue.
It could have been directed just to you.
Okay, I can't see the chat unless I quit sharing the slides.
So I think I see the question you're talking about. It says, one cannot continue to use legacy systems forever. What are your thoughts on how a company can move from working legacy systems to more modern systems that does the same thing plus more? And I think this is a really great key question. My first choice is always that we take the existing system and we iterate upon it to until it gets to a SLO, that we have a service level objective defined for this service, and that we take the existing system and try to bring it up to that standard. Because again, the problem with legacy systems is our ability to operate and maintain it. It's not the age of the system. So sometimes that does mean changing the fundamental technology that's at play. And if we're gonna do that, then we didn't make the decision that that's the path we want to go, and we understand the trade-offs in doing that, then we should do that. But it's a real important thing for all engineering teams to develop skill sets around how to gradually transition between old and new systems, because there is no engineering team on the planet that has stood something up and then never had to do any kind of migration, right? Either databases migrations, there are platform migrations. So all engineering teams need to develop a comfort and a discipline with doing these kind of, okay, we're going to gradually move the traffic over from the old service to the new service and make sure that everything goes smoothly. So like, I don't see it as like we replacing the old system with the new system. Even when we are rewriting things or migrating to a new solution as part of that. I see it as taking that old system and like gradually iterating on it until it meets a certain service level objective.
Thank you very much. Is there another question?
There is.
Okay.
You see it
Okay,
now?
you can see the questions now?
Yeah, I can.
Okay.
Maybe I'm the only person that needs to. Any advice for someone recently assigned to the maintenance of a suite of legacy systems, Power Builder client code? I'm learning the language. A different group is creating the replacement. Oh, I feel for you. Power Builder, kind of like the words I hear are my nightmares. I think this is an approach that people really love that I actively discourage them against, of having like one team assigned to the maintenance of the old system while another team is assigned to building the new system. And the reason why I dislike this approach is because think of the incentives. Again, you have the team that's in charge of the old team of the old system could see themselves as working themselves out of a job, right? You have two groups of people who are immediately set up to not want to help each other. And so a lot of times the team that's building the new system needs the knowledge and expertise of the people who are maintaining the old system. They need to know in detail, okay, this set of functionality, like what are the edge cases with it? Why is it built this way? How is it actually supposed to work? Right? And that lives in that maintenance team. So by creating two separate teams and saying to one team, you are the future, and the other team just going like, well, we're going to put you in the closet and like, maybe we'll get rid of you at some point, or maybe you'll have another job on the end of it. You create a very dysfunctional system out of the bat. A lot of times, and one of the reasons why I spend a lot of time talking and coaching and working with engineers, but I also spend a lot of time working on the C-suite, is because from the perspective of a software engineer in this kind of system, you can talk to your management and like give them the advice I just gave you and like say, hey, that we should do this in a different way, but you're somewhat limited in your ability to really resolve this now problem that they've created for you. I would say if you can create a different conversation between you and the other team so that the assumption is that when the new system is fully rolled out and everything is transferred over, you're now a member of their team rather than on the maintenance team for the old system. That is a much preferable situation than that separation with like the two teams.
And the next one, if we don't want to get stuck taking care of a legacy system, what should we be doing with our existing systems that are not legacy yet? How can we evolve what we have? Is there some sort of upgrade schedule that we need to be following?
Yep. I mean, sing the gospel of service level agreements and error budgets, right? They're not just for web-based systems, they're for every system. And when you indoctrinate the business side into thinking about systems in this way, then you have this ability to have a conversation with people about why it's necessary to like resolve technical debt, why it's necessary to move from one form of technology to another form of technology. What I did in environments where that was too foreign was to use kind of the methodology of success criteria. If you're familiar with OKRs, objective and key results, it's a very similar framework. It's a little simplified version of that, but it's essentially getting everybody in the stakeholder group for a particular system to define what success looks like. Because a lot of times what we'll see is that people talk about systems the same way, but their actual the evidence that they're looking for to indicate that they're succeeding in something is completely different. And I was on one team where one group of engineers saw this metric going up as success, and one group of engineers saw this completely different metric going up as success. And so they were at odds with one another, where like one group succeeding was like seen on the same dashboard by a different group of people as like, oh no, we're heading in completely the wrong direction, this is all wrong. So from the very beginning, getting people to sort of sit down and articulate, what do you think success is, and how do you know we are moving in that direction? Like, what are you going to be looking at that it will indicate to you that things are going well? Getting them to actually articulate that information and think about what that would look like for them helps get everybody on the same page and get everybody aligned, which helps make a really compelling argument for like why we're doing the maintenance when we're doing it.
And the
I gotta
next,
see Y2K in the chat room.
yeah. Yeah, that the next question coming up says that description of gradual improvement reminds me of how Mozilla is slowly replacing critical components in Firefox with new
Yeah.
components written in Rust. What do you think? Do you think that's a good case study for that people should follow?
I mean, potentially. I want to see how it ends up. I used to love Firefox, and lately I find that it's like really, really heavy handed. So I know one of the other things they're trying to do is improve the performance of it. And I I'm real rooting for them in that regard, because I think ultimately I'm a person who believes in competition. I don't like the idea that like Chrome is just gonna like be the dominant web browser for everybody. But I think the jury's a little out on it. I believe in the caliber of their engineering talent that they have been able to recruit historically and still have. So they have all the skills they need to be successful at it. But it's a little time will tell. I don't at all disagree with their approach, and get I really understand why they're going deep on Rust. And I think that from a technical point of view, in terms of memory safety, that is especially given that it's a browser, that is probably the right decision to make. So we'll see. Very hopeful.
Yeah. I see the comment about the Y2K cutover and Cobalt.
Yeah, and the thing I love about Y2K stories is that I think most people are unaware that like not everybody fixed their Y2K problems. Some people just said, like let's just ignore it and like put it off for another X number of years. This is something I go to into in the last chapter of the book around these kind of thorny issues, and how I think it's interesting that the general public consciousness around Y2K is that, oh, it was a hoax. And I'm like, as a person who, like, my father was one of those software engineers who had like cots set up in the basement of the banks, like working on like modernizing old COBOL code. I'm like, it was definitely not a hoax, but it started like 3 years before you would ever heard about it, right? So I think these kind of stories are really interesting, and the extent to which people were prepared for, let's say, the Unix rollover that's going to happen in 2038 and all of that is really compelling to me. I think we've got some fun left in the legacy modernization narrative.
Yeah. What's the most challenging system that you've ever had to work on a modernization project for?
I think the most challenging system was probably some of the stuff that I did at the IRS. Not really because the systems themselves were in bad shape. For the most part, they weren't. They were old, but the technical staff at the IRS were some of the best technical people I'd worked with in government. They took it very, very seriously, and they knew their stuff, right? And they were committed to it. But because of the nature of what that organization does, they would do these really, really long, like months long code freezes. And that made long term planning and the kind of like migration and modernization work you might want to do really difficult. But But at the same time, going back to the thing that attracted me to that work and that environment in the first place, there are no bad guys, right? Like if you think about what a tax cycle is, like people think about tax season as starting in April. No, for tax professionals, it starts basically December, if not January, right? And so people start filing the tax documents at all of these different times in huge numbers. And so, yeah, why do changes on a system when that is going on, right? Like a screw up during tax season would have such dramatic impacts on both the organization of the IRS, which is constantly under fire and like political pressure, but also just the government as a whole. Like, why take the risk? And so you could perfectly understand why they would do like these 6-month code freezes where like no changes we're going to touch production at like for any reason. But at the same time, from a software engineer's perspective, it was so difficult to like you would run, fight, because you knew that if you didn't get it finished by this date, you had to wait essentially like a whole year before you could try again. Like that whole challenge just made it like really super difficult to like work on these systems and like figure out how to improve them. Like the IRS is like one of the few places that like if I had an opportunity to go back and work there again, I would immediately quit my job and go back into government. I think I will go back into government at some point because I genuinely loved it. But like the IRS is one of those places that like without question, I would go back in a heartbeat. So the work is so interesting and the challenge that they have is so compelling.
Yeah, one thing I noticed when I worked with you and your team is you guys had such a non-traditional approach to things. And
Sometimes
do,
intentionally.
do you think your non-traditional for tech background might have influenced how you manage some of these engineering teams?
I mean, it definitely does. For me, uh, and in some ways, for the organization that I was working for, and those of you who are not familiar with what's been going on in the government in the federal government in terms of modernization, I was recruited by an organization called United States Digital Service, which at the time was very very young and very very small, to come in and be kind of a SWAT team type technologist that the White House could just send wherever there was a fire. And so I got to go around to a bunch of different organizations and interact with very senior people at a very high level and try to fix the problem. And I ruffled some people's feathers within the USDS system, because there were people who were coming from a traditional engineering background who looked at it very much as like, well, these are issues with best practices in technology, and they're not doing these things, and they should be doing these things. So, for example, like waterfall is still very popular in the federal government, right? And so they'd be like, well, they're not agile, or they're not on the cloud, and like these are very for their perspective, it was very straightforward technical issue, and like we're just going to come in and we're just going to do it, and then it will be fixed, and then we will leave. And I came in and I kind of like immediately looked at the situation very differently. And a lot of that had to do with that background that I had. I came in and I looked at the situation, and what I would say to people who came in after me that I was mentoring and training is that, like, if you see these problems, I guarantee you there are at least 5 people in this organization that have been screaming their heads off about those exact same issues this entire time. And the older the system is, the more people there probably are somewhere in that organization, on contractors, in like the lower rungs of the civil service, who see those problems and have been saying the exact same thing. I perceived my job and the job of my team to go in and find those people, figure out like with the ones that were on the right general path, kind of fill in the blanks a little bit for them. Like a lot of times we'd have people who had the right general idea, but they didn't know the right terminology, or they weren't up to speed on like the absolute like most modern practices around these concepts. And so we were able to introduce them to, let's say, rather than this enterprise software for version control, like here's Git. Like this is how Git works, right? We were able to sort of like fine tune some of the ideas they already had. And then what I tried to do was like network them together so that they knew who they were in the organization, and then get them the visibility and the voice in the leadership that I had access to. So I potentially had access to the deputy secretary for that agency. I potentially had access to the C-suite equivalents. They didn't have access to it, but like I could bring their voices to the conversation and like escalate their concerns. And what my goal became in that situation was not to fix the system, but to empower the people who were already there who had the skills and abilities to fix the system. And the reason why I pressed very hard on that approach was, hey, I'm leaving at some point, right? Like this is a term contract. I have been hired for 2 years with the opportunity to extend it for another 2 years. Legacy modernization projects are years long projects. Like I am not going to be here to see this cross the finish line. And even if I am not going to be here to like maintain it, right? So it's more important that the people who are going to be here for the long term are the people making the decisions and owning them than it is that like I tell them, I come down like the sagely genius and say like, do these things, here's your new architecture, like, and try to do things for them. That was a very, very different approach and a very controversial approach for a lot of people within that system and within the community of government workers we were trying to help. But for me, it was more effective, and it was a direct result of being in a social science environment and also being in an environment around international development. We learned a lot about how to sustainably help people and communities from failure in international development, as it turns out.
Have you ever had, and I'm sure you have, but have you ever had a situation where you just had to cut your losses and start over in a different direction?
All the time. And it's like, I always, it's heartbreaking when it happens because you want to, like, you don't go into this type of work um expecting it to be easy. You go into this type of work because it's hard, right? And because you do get a little bit of a buzz when you're able to solve a super hard problem. I think regardless of whether you ever touch a legacy system, as engineers, we can all appreciate and understand how much fun it is to be the person that cracks even a small part of a really hard problem. And so whenever I have to pull out without having solved that really hard problem, it is a difficult thing. But the most important lesson that I learned when I was at USDS, the very first administrator of USDS, a guy by the name of Mikey Dickerson, and what he taught, one of the things he taught me that I really valued is he said to me, I want every single person that works for me to know that they could quit this job on Friday and have like job offers from other companies on Monday. And what he meant by that is that when you are willing to walk away, you make better technical decisions. When you're not willing to walk away, you make dysfunctional technical decisions because you're scared about losing your job, you're scared about like getting a bad performance review, you're scared about all these other things. And so I try, whenever I'm in that position of thinking like, oh god, I can't fix this problem, it's usually an organizational problem rather than a technical problem. I can't fix this problem, I have to walk away. I think about that. I think about, well, what would staying mean, and would the quality of those decisions that I would make in order to have to stay be decisions that I'd be proud of as a technologist? And if the answer is no, then it's really time to go. This is the challenge with thinking about technology as kind of a contextual thing, is that sometimes people have really counterproductive priorities that then they're not going to change their mind. And you're dealing with people who are not necessarily engineers, and sometimes you can't reach them. And the best thing to do at that point is to stop enabling things to continue to limp along and to just allow them to fail. And that's super hard, but also sometimes necessary.
There was one question I think we missed from the chat earlier on.
Oh,
If,
did we?
if security was not, maybe you've already got this one. If security is not an important property in the original system, how do you produce more of it and maintain a proper balance with the other requirements and properties?
Oh, I mean, I always used to scare the crap out of people. So I love testing. And by that I mean both unit tests, but also failure tests, penetration tests, game day exercises. And so whenever I feel like we are not appreciating the seriousness of the risk we are taking on, I get a tiny bit sneaky about things in order to kind of throw that risk into a starker contrast for people. So sometimes that means that I talk them into doing a red team exercise and then let the red team just like basically go to town on these security problems. Sometimes that means that I find a friend in the legal and compliance side and essentially get the organization to do their poems, right? Write down the risks that they are accepting and then really get a sense for how many risks that they are accepting. But I like to scare the crap out of people rather than continue to make arguments about how important security is. Like I was telling an engineer the other day, like organizations, because I was in a meeting where an engineer said, like, well, you know, like this organization will grow to a certain size where they will get a nice stable form of income and then they will care about security. I'm like, nope, stop, full stop. If they don't care about security on day one, there is no level of revenue where they suddenly care about security. Like that doesn't happen, because whenever they get to what they think that stable, like now we have arrived level of revenue is, they're looking at the next 100 million, 1,000, whatever, right? So like there's never a point in which they decide, oh, well, now it's time to think about security. Only time organizations like that think about security is when they have touched the hot stove and gotten the 3rd degree burn, and then suddenly now they think about security. So like I get I can be a little bit brutal in these kind of situations, but I think that when people don't understand how important these issues are, they need to have it reframed for them in a way that makes it something that they can understand.
And another thing is, I've worked for a couple of different organizations in the government right now, and there seems to be a big push rather than rewrite code and refactor legacy solutions, is just to go ahead and buy COTS.
Yes.
And I don't know, what are your thoughts on that?
It's like, again, there is no silver bullet. Like COTS is great. For a lot of problems, that's the right solution. And I think it was funny because that generation of technologists that came into federal government at the same time that I came into federal government did run around saying like, buy COTS, buy COTS, buy COTS, buy COTS. And then they saw some organizations do exactly that in a way that they understood, oh, that's the wrong thing, right? Like, and then they go like, oh no, we didn't mean like that. And so it was this funny, like, be careful what you wish for sort of a circumstance. The thing that I tell people is it's about how well that COT solution fits what you are trying to accomplish, right? So if you are looking to host a blog or just a standard website, right? Like WordPress is a tried and true tested solution that has a huge group of people that know how to maintain and scale. And so use WordPress, right? If you're trying to do different types of not processing pipelines, oh shoot, I forget what the name of it is, but essentially like a sales pipeline or something, like a Salesforce type thing is very flexible. But especially where you and I were overlapped in the government, there are lots of situations where the actual problem and the actual thing the government is trying to do only exist in government. Like as far as I'm aware, Google does not have a standing army, right? So there are a bunch of different things that the DoD does that are very unique to what the DoD does, and there's unlikely to be a COTS solution that actually fix that. So it's really about understanding, like, if we use the solution, what level of customization would we have to do to get it to do what we needed to do? And like, there is a point where that level of customization should seem scary. The thing that I'm more concerned about than costs is actually the low code, no code solutions that are being shopped around, because I think for non-technical people, they don't really understand the extent to the junk code and the inefficiencies that those solutions sometimes inject when you're not, again, well aligned to what they're designed to do, right? There are low code solutions where it's like, this is for building X type of thing, and if you're building X type of thing, then fine, right? But there are low code solutions that are promoting themselves as like, you can build any type of application, and like, I'm very skeptical of those claims.
We got another question from Chad. It says, one industry in the middle of modernization, probably for decades already, is the railroad signaling. There are tons of legacy systems still in use today, including relays wired together, or even mechanical decision mechanisms. The new or newer systems utilize microprocessors, computer systems, network, etc. Maintainability are certainly concerns. The old systems have lasted for 50 years or more in some cases, but of course, finding qualified staff to work on those is difficult.
Yeah, I mean, I'm from New York, so I know all about railroad legacy technology. Like the New York City subways system famously has some control systems from like the 1920s, which like blows everybody's mind all the time. And this, I think, is a very fun, quirky manifestation of the kind of age-old dilemma throughout legacy systems. When do you move off of this system that has you have a history with, that is proven to be very reliable, but that you're afraid that everybody who knows how to maintain it is going to die off? And when do you train and start to develop your own in-house talent? There really isn't a right answer here. It depends, again, on the organization's tolerance for it and a little bit on economies of scale, right? Like, if you are running a huge railway system, you could frankly have your like own academy and like train your own people and continue to run those technologies. Often the problem with these things isn't so much training the people to operate and maintain them, it is finding the parts for them, right? And so I know specifically with like a lot of the New York rail systems, they've had to like gut all, like strip things from like scrap heaps and like go on eBay and like do all sorts of things, because all of the companies that built these technologies, they either don't exist or they've decommissioned all of this old technology. So there's that factor in, but the other thing to factor in on the other side is that a lot of the newer systems that we're building are very complex and they have a lot of dependencies. And that sometimes means that they are not particularly resilient in like moments of unexpected failure, like a power outage, or like you can have these kind of like really colossal system failures, and some of the older systems have a level of simplicity that means that it can sometimes be easier to sort of like figure out a way to get them up and running again, or manually override them. And so that's another concern that one has to think about when you're looking at like what's the correct approach to dealing with these kind of systems.
Yeah. So we're getting close to the top of the hour. Is there just throwing it out there for you to take the last bit of time? You can talk about your company or your book or how to contact you for speaking engagements, whatever you want.
So you want to like just move the slide?
Okay.
I do not have a QR code. I didn't think to do a QR code for this meeting, but now I now learn, and I will do a QR code in the future. You can find me on most social networks as Belmar. Twitter used to be the main one, and there's a couple months ago, someone started a Mastodon for type theory and language design, and that was the thing that convinced me to sort of get a Mastodon. So if you're a Mastodon fan, I'm also a Mastodon right now. And the website where I kind of aggregate a lot of my content is Belotti.tech. And progressively, I've been investing more and more time into sort of developing methodologies around online courses and training. You can reach out to me if you want me to come talk through there as well. So any updates on future books will be posted there. It's great. Oh, the Mastodon instance is types.pl, which I was also a fan of. I'm like, that's the greatest name for the greatest things.
Well, thank you, Marianne, so much for joining us and sharing your knowledge of this subject with us. And I really appreciate the talk.
Yeah, thanks for inviting me. It's been great.
And I think at this point we turn it over to Alan. And I'll
Yes,
stop sharing.
copying a couple links here, and then I will be ready to share my screen again. Okay, so let me get mine back on, and I will share my screen.
And while you're doing that, I'll show the book one more time. It is a very good book, and I can attest to some of the content in this book I personally witnessed. So
Okay, just a quick reminder, if you currently aren't an IEEE member and you want to join IEEE or any of its societies, just go to IEEE.org/join. And if you're already an IEEE member and you're not sure that you've already renewed your membership, go to IEEE.org/renew, and it'll let you know whether you've renewed or not. And if you're a student, either joining or renewing, make sure you use the discount code Future50. That will give you 50% off the already low student rates. And if anybody is going to be in the Richmond, Virginia area, Sunday, February 19th or Monday, February the 20th. There are tentative plans to bring the IEEE Move disaster response vehicle to the Science Museum of Virginia for Celebrate Engineering Ingenuity Day. That's a K through 12 STEM event. If you're not familiar with the IEEE Move vehicle, IEEE provides assistance to the American Red Cross, and when they get a disaster situation and all the power's down and all the cell towers are down and everything is down, they send this vehicle in that is self-contained, satellite links, networking, so on and so forth, and they provide the connections that the Red Cross needs in order to do the disaster relief work that they do. And when they're not doing disaster relief, they use it for STEM outreach. So it's going to be, there are tentative plans. This is just as of late last night. So that's why they're still tentative, to bring that to the Science Museum on the 19th and then Virginia Commonwealth University the next day. As I mentioned, we are recording this meeting. If you're interested, we've also recorded previous meetings that some people might be interested in taking a look at. We had a cybersecurity a panel session recently on software bill of materials. We had a talk on technology predictions and future of work. Another one on deep learning for biomedical and healthcare applications. We had a talk about a panel session, what every software developer should know about cybersecurity. This was a number of people whose daily work was cybersecurity, about what they wish people knew about cybersecurity so that they had an easier time on their end. And we even had a talk on if you wanted to learn how to program quantum computers. We had somebody from a quantum computer company, and they were offering free time on their quantum computers and showing you how to program them. So all of these links will be in the recording, and I'll send the link to this recording out to everybody who registered once we've got the recording posted. And that's all I've got.
So real quick, Alan, someone in chat is asking if we could do CEUs for IEEE members.
Yeah, here, let me see if I can get the chat. I've got to stop sharing my screen so that I can get the chat to.
I mean, as a person myself who continually chases continuing education points, I see that's pretty much a good thing to get.
Let's see. I'm just going to copy the whole chat. I'm not sure if it's going to. Hopefully, it will give it to me when I go to the administrative page, but just in case. Okay, what we do for people that want CEUs, the definition of what you have to do to call it a CEU varies from one state to the next. So what we can do is we can give you something that says you attended and what the topic was, how long the thing lasted, and whether that is sufficient to count as a CEU is between you and your state and whether they say that's sufficient or not. So I can't promise that it's going to count as a CEU. That's something you'll have to figure out. But we can send you something. Okay. Any other comments, questions? Okay. Thank you, everybody, for tuning in, and especially thank you, Marianne, for coming and speaking with us.
Ah, my pleasure. It was great meeting everybody. Night.
And yes, but somebody was asking link for this video. I'll be emailing that out once the video is posted online. Okay, thanks. Bye.
Great seeing everybody. Have a good night.